Hello everyone, we are starting and continuing our vectors sections. Today we're going to talk about what is a resultant vector and do two application problems. It'll take us about 15 minutes, so prep up, okay? So what is a resultant vector? So really quick, a resultant vector, write this down with me please, is the sum of the vectors. Basically what we say is it's the addition of the x components and y components. So x is going to add to x's, y's are going to add to y's. All right, so that's a resultant vector. Now I'm going to show you that idea in the next example. We are going to be writing a lot, so try to write as small as possible. If you are not a person that writes small, maybe have another piece of paper handy, because the more organized you are, the more you'll understand how to solve these problems, okay? So let's look at example 1. So it says a force of 100 pounds at an angle of 20 degrees acts on another force of 80 pounds at an angle of 100 degrees. Find the magnitude and direction of the resultant force. So we need to find the resultant force first, and then we can figure out the magnitude and direction, and that's what we did yesterday. So with the resultant force, in order to find the resultant force, first you need to figure out what each of the forces are, meaning find each of their vectors. So I'm going to draw the vector, the first vector, which is coming from this one right here. It says a force of 10 or 100 pounds at an angle of 20 degrees. So image wise, I'm going to just draw it out. I see an angle that's 20 degrees. The magnitude is 100 pounds. And I'm just going to drop that triangle down, and I know that this is my A and Y is my B. Okay, so what we need to find is our X and our A and our B, or our X components and Y components, and then we can figure out what the vector is. So I'm going to do quickly cosine of 20 degrees equals A over 100. So if I multiply 100 by both sides, I get 100 times cosine of 20 degrees, and A is approximately 93.969. I already did this on the calculator, so that's why I have my numbers ready to go. All right, so that's the A component. Then we're going to go ahead and find the B component. So let me just do the B. So it's not cosine, that's not true. Once it's B, then we're doing opposite over hypotenuse, so that's sine. Sine of 20 degrees equals opposite, which is B over hypotenuse, 100. So B equals 100 times sine of 20 degrees. And B is approximately 34.202. Now, I always like to double check my triangles in quadrant 1. A and B are both positive, so that is my vector 1. So my force 1, because they keep talking about forces, the vector for my force 1 is 93.969 I hat plus 34.202 j hat. Okay, so that's my information for the first force. Now there's a second force in the play, and so we're going to do the exact same thing for the second force. The second force is 80 pounds at an angle of 100 degrees. So I'm going to draw that image really quick. 100 degrees is in quadrant 2, and it's 80, so it's a little off, my numbers, sorry guys. So that's 80 pounds for my magnitude. And I'm going to draw my triangle. So my triangle is in quadrant 2. And the angle that's inside, so the angle is 100, but the angle inside the triangle is 80 degrees. So that's what I'll be using to solve my A, which is my X component, and B, which is my Y component. Okay, so we're going to do the same thing that we did in the other one. So I'm going to do cosine of, all right, I fixed it. So now we have the sine of, Oh no, that's not true. Cosine first. I want to solve A. So cosine of 80 degrees equals A over 80, which is my hypotenuse. And then we get A equals 80 times cosine of 80 degrees. And A is approximately 13.892. Now, it is going to be negative since I'm going in the left direction. So this is negative 13.892. Okay, so we are in quadrant 2. That's why I made it negative. All right, for the sine of 80 degrees equals opposite over hypotenuse, so B over 80. So B equals 80 times sine of 80 degrees. And B is approximately 78.785. And since I'm going up, that could be positive. So my force 2 is going to be negative 13.892 I hat plus 78.785 J hat. But they didn't ask me for my individual forces. What they wanted was the resultant force. And what the resultant force is the sum of these two forces together. So what we need to do is we need to take the first force plus the second force and add them together. So we're going to add their components. So we have 93.969 I hat plus 34.202 J hat plus the second one. Sorry, I'm going to zoom in a little bit. Plus the second one, which is negative 13.892 I hat plus 78.785 J hat. And then we're going to add them up. So we end up getting 80.077 I hat plus 112.987 J hat. And this right here is my resultant force. So it's the forces together. Force 1 plus force 2 together. All right. Now, they wanted the magnitude and the direction of this resultant force. So we're going to do what we did yesterday and solve for magnitude and solve for direction. Okay, so I'm going to take that resultant force and find the magnitude and direction. So I'm going to move it over a little bit. I did not give myself too much space. Sorry about that, ladies and gentlemen. Please have another piece of paper or try to write it on the other one. The next one isn't as long as this one. All right, so let's do this one. So now we have our resultant force, which is 80.077 I hat plus 112.987 J hat. And what we're going to do is find the magnitude. Okay, and in order to find the magnitude, we take the square root of A squared, which is 80.077 squared, plus 112.987 squared, and that's our magnitude. Okay, so when you type that into the calculator, you're going to get 138.486 pounds. So since they were talking to us in pounds, we're going to keep it the same. So that is the magnitude of the resultant force. And that's one of the things they wanted from us. The other thing they want from us is the angle, the direction. Okay, so we can do tangent inverse of B over A, which is 112.987 over 80.077. So this is what we did yesterday, and we end up getting 54.674 degrees. Now I'm going to check, since A and B are both positive, I am in quadrant 1, and so is that angle, which is great. So that means that's the direction of my resultant force. So all that work to answer those two questions. All right, so it's not complicated, it's long. Because what we did, let's just kind of preview a little bit, is we drew each of the forces separately, finding its force components, x and y, doing the same thing for the second one, x and y, and then adding these two forces to get the resultant force, and then taking that resultant force and finding the magnitude and the direction of the resultant. And that's all the work that we did here. Okay, so if you need to rewatch it, please rewatch it, because I know you can do this. All right, let's look at the last example that I have. Last example is similar to this idea. It says a plane travels at an airspeed of 400 miles per hour due west. A 50 mile per hour wind hits the jet at an angle of 100 degrees. Find the resultant ground speed of the plane and resultant direction. So this is their other way of saying find magnitude, and then they were clear on this one, finding the direction of the resultant. So we once again have two forces. We need to get those forces together first before we even start magnitude and direction. Okay, so let's look at the first force. The first force is an airspeed of 400 miles per hour due west. So west is going left to me. So I'm going to go ahead and just sketch it out. This right here is 400 miles per hour. Okay, so if I were to, I don't even have to do any work on that. My components would be, for my vector, my plane 1, force would be negative 400, because I moved left 400, I hat, and I don't go up at all, so plus 0 j hat. So that is my force, which is awesome because I didn't have to do much work. Let's look at the second one. The second one is in quadrant 2, 100 degrees. So if that's 100, we know that once the triangle is created, inside the triangle is 80 degrees. And the amplitude, or I'm sorry, the hypotenuse is 50 miles per hour. Okay, so that's our hypotenuse. And we have our A and B that we have to solve. So we're going to go ahead and do cosine of 80 degrees equals A over 50. So I'm just doing Pythagorean theorem, or I'm sorry, I'm doing trigonometry. Opposite adjacent over hypotenuse, and then opposite is my B. So now we have A equals 50 cosine of 80 degrees, and therefore A equals 8.682. But since I'm going left, it has to be negative. So that's my A component. The B component is going to come from sine of 80 degrees equals B over 50. So B equals 50 times sine of 80 degrees. And we end up getting B is approximately 49.240. And since that's going up, it's fine. Leave it like that. And my second force is then negative 8.682 I hat plus 49.240 J hat. Now, the total force, okay, so we can do, that's the resultant. I'll just put an R there so you know. That's the resultant right there, okay, is pretty much the first one, first vector, plus the second vector. So we're going to go ahead and add their components, okay. I'm ultimately adding negative 400 and negative 8.682, getting negative 408.682 I hat. And then I'm going to do the same thing for the y components, getting 49.240 j hat. So that is my resultant right there. That's the resultant force. Two forces together. And what they wanted from me was the magnitude and the direction from there. So I'm going to go ahead and do the magnitude of the resultant by doing Pythagorean theorem. Oops, forgot the squares. Which is approximately 411.638 miles per hour. And then the direction, which is tangent inverse of B over A, which is approximately 173.13 degrees. All right, well done today. I'll talk to you later.